So this is going to be the shorter version of my previous video. I'll try and make it fast. So the double slit experiment, the problem is that it seems to be that we're experiencing a particle and a wave. It's like sometimes it's a particle, sometimes it's a wave. So what's going on? So I'm assuming that the fabric or that space is not a vacuum, rather, space is a fabric, the same fabric that we realize that it is in general relativity. It is almost a solid. So that's the assumption, and that's explained in the long form of the video, how I came to this conclusion directly from general relativity. So particles cannot travel in solids, obviously. The only thing that can travel through a solid is a wave. Okay, so the emitter creates a particle. This particle, in order to traverse any distance in space, even in a vacuum, it doesn't matter, it's all the same, it's all a solid. Let's call it the space solid. Instead of calling it the space time continuum, I call it the space solid continuum or the space fabric continuum. I don't like space time, that's for a different video. So the space solid continuum, all right, so the emitter creates a photon or an electron, whatever. This particle, in order to traverse any distance, must convert into any distance relative to the observer. Must convert the observer, I would say, is the detector at the other side. So it must convert into a wave. So it converts into a wave. The conversion to a wave is readily available through E equals mc squared. So the particle m can easily become energy and travel as a wave, a pure wave. So the particle converts completely at will, at the snap of a finger, it converts into a wave. The wave is the energy that was the particle. Now there's no more particle, there's only a wave. As far as the detector is concerned, there's a wave traveling towards it. The wave interacts with the universe and creates an interference pattern as per Schrodinger's equation. So Schrodinger describes here a simple wave equation because it's simply a wave, and that's exactly what Schrodinger assumed. And this wave creates an interference pattern at the detector, at the backboard, whatever. And but as this wave stops, it cannot stop as a wave. A stopped wave must convert back into a particle. It converts into a particle or into something that the detector detects. I don't know exactly what the detector detects, but that's as a particle. So that should be the same particle or the particle with the same energy that left. I guess because the conversion, it's really weird because as a wave, it's a three-dimensional wave. It's really a sphere expanding from the emitter. So it's a spherical if it's a photon, then it's an electromagnetic wave that is waving all around in 3D space. But some of these waves end up at the detector. So I would say, anyway, whatever, we'll come back to predictions that we can make from this model, but that's the model. So a particle is emitted, a particle cannot go through the space fabric continuum. It's basically a solid, so it can't move. In order to move, if it wants to move, then it must convert by E equals mc squared from mass into energy. It converts completely into the energy wave, electromagnetic wave, if it's a photon, converts to a pure electromagnetic wave, goes through two slits, interferes. There's an interference pattern because it's a wave, that's normal. Hits the detector, right? The interference pattern is the wave that arrives at the detector, and but then it stops and becomes a particle again through again equals mc squared. And I think that's it. So that's it. Let me stop the recording here. Thank you very much.